Good morning, everyone. Happy December 1st. It is December. So however you feel about that, it's December. um, you are on day 2 of HVAC systems testing with Lester. Excited to get into the equipment today. Let's see, next slide. We don't have a lot of intro this morning. Just a reminder, ask all questions in the chat, any and all questions. We'll get to them. And one last class for the lighting design lab is less of a class, more of a case study. Next week, it's going to be very interesting, a panel of about 5 or 6 of the folks that were involved in that. And I'm going to change presenter over to Lester and let's get going.
All right. Sounds good. Let me get this up and we'll have Danny run through some really quick rules of engagement for those of us that were not able to make it on Tuesday. Give me one second here.
Absolutely. So I just wanted to say welcome everyone. My name is Danny and I'll be your moderator today. So I'm here with your instructor Lester and we will be running through the HVAC systems testing for energy efficiency course. So we're going to be together for around 2 hours today, and our goal is to take a break somewhere in the middle to fill up some coffee mugs, stretch, maybe use the facilities. But today we're also going to be using the chat feature for any questions that come up, and there's going to be some scheduled pauses in the webinar to address these questions. Based on how we're doing with time, we're hoping to provide an answer to all of your questions. And we're also going to be using Slido today, and this is going to be accessed through your smart device. I highly encourage everyone to take advantage of those polls, surveys, and questions. So I'm going to be in the background providing some links and resources in the chat, so you can look out for those. But without further ado, I'm going to hand it off to Lester to kick off HVAC systems testing for energy efficiency.
All right. Danny, thank you for that. And like Danny said, we will be utilizing the chat function for any questions. Please look out there for any type of resources and links that Danny will be sending out today. All right, so let's jump right into it. Once again, welcome to HVAC testing for energy efficiency. My name is Lester Terrance. Today I will be your instructor. I am an instructor and instructional designer at DNR International, and I hold a master license in HVAC. I've been in the industry since 2003, started my career as an airman in the United States Air Force, where I learned about HVAC applications and worked my way from a beginner to a master HVAC once I departed from the Air Force. After my service with the Air Force, where I had the opportunity to travel to several different countries and work on HVAC applications, I went ahead and got an opportunity with the State Department, where I spent an additional 7 years working as a subject matter expert to the State Department and its embassies and consulates around the world. I also was responsible for the supervision of 7 preventative maintenance teams that spanned the globe. Several different countries where I had the opportunity to make QC, QA trips, and also any type of training that was required for those technicians. I was responsible for providing it to them. So it has been roughly about 20 years I've been in the field, and I have many different experiences with different types of applications and equipment under HVAC. And it's been a pretty fun ride, but now I'm here working with DNR to give back my experiences to the public, so that way they're more aware of these different HVAC applications, tools, and instruments that are out there to assist in making sure that your facility is running at its optimal levels. All right, so Danny mentioned earlier, we will be using Slido.com for our interactive sessions. You will see a QR code in the top left-hand corner of the screen when we do have those opportunities present. Please participate in these sessions. It will just help to further enhance your understanding and knowledge of the subject at hand. So the event code is going to be EEHVAC or EEHVAC. and you will enter that if you go directly to slido.com through your browser. If you would much rather scan the QR code with your mobile device, that may be a lot easier, and it'll take you directly to the activity polling session as it is present. So what we're going to do first is, for those of you who are here Tuesday, we kind of went through this already. It's an introductory survey, and what it does is it allows us to, one, make sure that Slido is working for all of our attendees. And two, what it will allow us to do is get a brief introduction to the members that are in class with us today. I'm not sure if the survey has a spot for telling exactly what your background is in, but if you are able to annotate that somewhere within the question part of that survey, please do so, just so we have an idea of what type of backgrounds we may have in attendance today. So what we'll do here is we'll give maybe another 4 minutes for us to go through the introductory survey. For those of us that were not here on Tuesday, you have an opportunity now to fill out that survey or just say hello. Tell us how you're doing. And then from there, we'll go through those answers and we will go through a brief review of what we covered on day one. Just want to let you all know that my video feed will be in and out throughout the day. This is just to conserve bandwidth throughout the day as we're moving through our presentation. Sometimes it may get a little sticky, and we want to make sure that we have the smoothest presentation possible. So let's take another 3 minutes here, go through the survey. I see we've got some people active in there right now, and we'll go through those answers here shortly.
And I just wanted to chime in here, Lester, real quick. I just put into the chat the slide deck. So it's a link to slide deck if you want to follow along. And we also have the Slido link as well as the code that was just sent out. So if you're looking for that, that is in the chat.
Awesome sauce. Thank you so much, Danny. Do appreciate that. Danny just linked some valuable resources in the chat. So if you are just joining us, please visit the chat in order to find out the code and instructions for slido.com. Also, there is a PDF version of the course today there as well. All right, so what we'll do is we'll get into this survey just to check in with everyone, see how everyone's doing this morning. So we have no tradesmen once again. Rate your level, your comfort level and understanding of HVAC. We've got 50% roughly just getting started, and then we've got 40% that about pretty good. Then we've got maybe one or two sprinkles of an HVAC guru in class and session today, so that's good to hear. Please, if you have any insight on anything that we're discussing, please feel free to share that, so that way we can have you shine for a moment here in class for those gurus that are here today. Rate your understanding of HVAC systems. I've heard of them at roughly 70%. I work on HVAC systems, 30%. So we've got a great deal of individuals that just know about these systems. But today what we're going to do is actually go through the equipment used to test these different systems. All right, so before we jump into today's topic, what we want to do here is just go through a brief a really brief review of what we covered on Tuesday. And where we started was we tried to define, or not tried, but we did define what is a mechanical plant and also an electrical plant, and the types of equipment that you will find and components that you'll find at these two different locations, which is valuable to an overall HVAC system in operation. So we covered mechanical plants where we started talking about what services are supplied from your mechanical plant and what types of equipment you'll find there. And one you will definitely find is that heating and cooling is two of the services that are supplied from your mechanical plants. Now, domestic hot water is also a byproduct of any type of heating application. So when you're talking about domestic hot water, that is also a service that is provided through the use of a mechanical plant. Cooling, where chillers are going to provide the cooling to commercial facilities, uh, you'll find that also all the components that are required will be located within your mechanical plant. So your chillers, sometimes your air handler, if it has a main system that branches off to other systems, any type of controls, and we'll talk about that here shortly, will be situated at your mechanical plant. You also have your cooling tower, your chilled water coils, which will be part of your air handling system, and also any chilled water pumps when you're talking about cooling within your facility system. Now, when you're talking on your heating side, you're going to have some of the same types of equipment, such as your heating water pump and also your hot water coil. But you may also have a chemical feed on your heating system in order to maintain the pH balance of your overall heating water loop. So your mechanical side of the house is going to host a lot of the main equipment that's going to be utilized to provide that comfort heating or cooling, or even if it's instrument cooling that is required, you will have majority of those services come from your mechanical plant. And also you'll have your water treatment as well, whether you do that in-house or you have it contracted out to someone else to perform those different measures for your system. Then from there, we covered the electrical side of the house as far as electrical plants. And we know that these electrical plants are going to provide the electricity required for the components in our mechanical plant to be operational. Some of those different systems range from your power solar generation to your electrical distribution systems and also your building automation systems. Now, we'll go back, talk a little bit about our power solar, and this is just the use of solar equipment or power generation equipment such as generators to provide any type of supplemental, secondary, or redundant power in case you have some sort of a power loss from commercial supply power. So that is the use for your power generation and also solar coming out of your electrical plant. Also, electrical distribution systems are part of your electrical plant where you have most of your transfer switches, your MCC, which we covered on Tuesday, motor control center, your transformers, and also UPS systems or lever systems as well. Building automation is also lastly one of the other types of controls that you have coming out of your electrical plant. And this is mainly for measurement and verification, control of any of your building lights and mechanical and electrical control services. So a lot of the time your electrical systems are going to be tied into your building automation, which will give you a great graphical view of everything happening with your entire plant, whether that's mechanical or the electrical side of the house. And we went in depth as far as talking about some of these different types of equipment, such as your air handlers, your chillers, your boilers, your heating pumps, your cooling pumps, which are the same, pretty much pumps, but you can use them either for heating or cooling, and also your hot water coil and your chilled water coil that is a part of your air handler unit or system. So today we'll dive a bit deeper into some of those systems. But what we will also do is talk about the instruments that are used in order to test and measure the efficiency of those different systems. So here we have some learning objectives like we just covered with the review on day one. We had an introduction to the HVAC systems, which require testing, meaning your mechanical and your electrical side of the house. and we discuss the different applications relevant to that plant's operation. Today, we're going to analyze testing and data acquisition tools. Today, we'll be able to recognize the different data acquisition components, and we'll also be able to identify the different HVAC measurement testing instruments available in the field today. Also, we'll go through evaluation and testing and go through an HVAC system jigsaw. Hopefully, if we have enough time today, I would like for everyone in attendance to go through this jigsaw, which is really, really cool at showing us some of the different instruments that are used in the HVAC field. And we'll talk a little bit about system maintenance and upkeep as we get to system evaluation and testing. All right, so let's jump right into things today. We're going to start off with data acquisition and testing. So what we want to do here is understand testing and data acquisition tools. We will examine automated testing methods used for HVAC systems, and we'll also identify the different measurement testing systems and equipment. Now that we have an overview of the different sides of the HVAC system, as far as talking about electrical plants and mechanical plants, let's look at how we acquire this data for analysis and the equipment we use for testing of HVAC systems. Here on screen, we can see a young man. Looks like he's testing out a breaker panel for or disconnect for the condensing system on an HVAC unit. Testing is important. We have to do it in order to diagnose systems. We have to do it in order to make sure systems are operating efficiently as possible. And if not, we need to make the adjustments to those systems in order to get it back to its original working order. Now, each component in an HVAC system requires individualized testing utilizing certain industry measurement and verification tools. Now, these testing measures ensures, once again, the optimum operation of HVAC application. Any type of faults, other issues that plague the system may be intercepted by using these different testing measures. Now, implementing control systems testing plans, instead of just going by or utilizing your standard testing HVAC instruments or equipment, if you were to implement control systems, this would help create a log, an automatic log of HVAC equipment operations. Now, this is something that I highly recommend as far as it being a practice. I think we touched on this on Tuesday about having logs, either the manual or hard copy versions located in every mechanical plant, electrical plant, and also mechanical room. And this is important so that way we have any type of historical records required to review any type of past operation for either audits or if we're looking to identify some sort of issue that happens on an irregular interval. Now, the different applications requiring system testing are some of the following. We have boiler systems, chiller systems, pumps, air handlers, and electrical systems. Now, this is just primarily to HVAC, but there are a lot of other systems out there that require different testing measures. But today we'll be talking about the systems or the components for HVAC systems. Now, please do remember any type of faults or other operating halting issues will be discovered and addressed before any bigger problems arise if you're utilizing your testing instruments regularly during your walkthroughs or any type of inspections that these different HVAC components require. So keeping up with maintenance is where you want to start, and making sure that your technicians are using these different instruments and providing you with that feedback they receive from them through or by way of some type of logging history. And if you use any type of control system, automated control system, building automation controls for your facility, you'll be able to streamline that process a lot more easier and make it automatic. So that way you wouldn't even have to really have someone responsible for that task. You could put equipment in the place of a human resource for that specific task. I will talk about that by touching on receiving any type of data or data acquisition through the use of sensors. These sensors provide you with continuous monitoring of HVAC systems or electrical systems through the use of a BAS or building automated system. So on screen, we can see the testing and data collection process, which we touched on Tuesday before we finalized Tuesday's session. But what we're going to do today is we're going to continue going through this process when talking about testing and data collecting, the process overall in itself. Here on screen, once again, you've got a 6-step process. Starting with step 1, you're going to determine the quantities to be measured. So what are those quantities to be measured? A lot of the time, we're going to talk about the more regular data capture points, such as temperature, pressure, differences in your temperatures or differences in pressure, which is often referred to as delta T, velocity, flow, and whether or not that system is either on or off. So those are just some of the different measures of quantities that you would want to measure through the use of sensors, which we're going to touch on shortly. Then step 2, as you can see, and as we go along, we'll bring this chart back in so you can see exactly where we're at in the process as we're talking about the different actions that are happening in each step. But step 2 is going to be determine that sensor location and what data is available. So at what point in the system are you wanting to capture this data? Is it immediately after the airflow leaves from being drawn through the coil on a cooling coil or a heating coil? Or is it when it blows directly into the space that it's required in at that point? So at what point are you wanting to capture the type of data that you're trying to capture, or the quantity that you're looking to be measured? What point in the system are you looking to capture this data? And another question that you want to ask yourself while on step 2 is, can some sort of a sensor or component on the market be able to retrieve this data? And we'll talk a little bit more about these sensors and what they look like so you can have an idea of what the industry has out there to offer. Your third step is to collect the raw data. During this phase, we have what is referred to as data loggers, which will be utilized to collect and store any of the raw data that is pulled or drawn from these sensors. Now, data loggers run continuously, and it transfers the information to a database or some sort of a PC database for analysis. This data is then processed and analyzed in step 5. So step 5, we're going to analyze this data for any type of audits we may have, troubleshooting we may be going through, or any type of repetitive issues you may be having with your system. And then finally, step 6, evaluate the output of the analysis. What are the problem solving steps required to solve any issues which may exist at this time? Do we need to upgrade our equipment? Are there any urgent repairs that need to be made? And lastly, is maintenance up to date? All of these questions can be answered after performing some sort of an audit through the data that was collected by the use of sensors. So very quick 6-step process to evaluate your system, make sure it's operating as optimally as possible. And by the use of, but not by the use, but by collecting data, you can use that data in order to find any type of flaws within your system. Especially, like I said and mentioned earlier, do you have any type of repetitive issues? Utilizing log data is a great way of identifying why and how some of these issues might be occurring. You may have a facility that is offline, or not offline, but doesn't have any type of activity once it shuts down, but the mechanical and electrical operation is still ongoing. So if you do have some sort of a BAS system that's there to record the activity that's happening through the evenings, you're able to find out where you're having that issue. Especially, it could be an issue that's going on during non-operating hours. All right, so what we're going to do now is we're going to touch on some of the different acquisition equipment that's utilized in the field, HVAC field, to get some of these different measures. So as far as temperature, humidity, water, air pressure, and also electrical data points, we're going to now show exactly what types of um, components are used to obtain those values. So on screen, what we can see here is we've got a few different types of data acquisition sensors as far as temperature sensors are concerned. So if we want to capture temperature values, we're going to use some of the following items that are located on our screen today. Starting towards the left-hand side, you're going to see what's called an ambient temperature sensor. Now, what is an ambient temperature sensor? An ambient temperature sensor is also known as an outside temperature sensor. So it's pretty much a device that monitors the external climate conditions. So it's a temperature sensor that is monitoring the temperatures outside or the ambient temperatures. Now, having one of these may help control the temperature and blower speed inside of your system if you're able to or not able to, but if you have a BAS system configured to allow that system to operate your interior system. So for instance, let's say you have both heating and cooling at your facility. It's a large facility, extremely large, but it utilizes ambient temperatures in order to operate the system in a specific mode. So let's say we're right in between that summer and fall phase, and it for some reason we're right there in fall, but it's still pretty warm out. What your ambient temperature sensor is able to do is realize that the temperatures outside are much hotter, which will lead to a much hotter interior. So it will automatically adjust the mode of your system to cooling because the temperature may have approached a temperature above a specific set point that's set for that system to go into cooling if the outdoor temperatures rise above a specific temperature. Now, if the temperatures were to go below a specific temperature, let's say 40 degrees, for instance, so 45 degrees Fahrenheit, then that system would be triggered to go into heating mode because now the system has been provided instructions that if the temperature goes below a specific or set amount, or also called set point, what will happen is that it is telling the system the temperatures outside are getting ready to reach uh, not unbearable, but temperatures that are not comfortable for human occupancy. So what happens at this time is using these different ambient temperatures or using an ambient temperature sensor will allow you to really automate your system. So that way your human resources would not have to play a part in that switchover. Um, Please let me know if you have any questions on that. But that is exactly how these outside temperature sensors, or also called ambient temperature sensors, work. Directly next door to our ambient temperature sensor, we have a thermostat. I know a lot of us are well acclimated with this device, this component here. And it's just a device which is used for regulating temperatures within a space. Um, this specific one we see here on screen is a Nest thermostat. I own and have installed one of these in my home. And it is a really cool device. It does a lot of automation on its own, does a lot of sensing, smart sensing, which just means that it is able to study your patterns of temperature adjustment. And then it creates a schedule for you, which automatically over time, you won't even have to make those adjustments anymore. It starts to learn your body, learn how you operate. But it's also a really cool device for having any type of load shedding or demand response actions that you may have signed up for with your utility company. It will provide them access to controlling your system if that's something that you're a part of. It will allow them the utility access to control the system so that way it could take part in any type of demand response event. Over to the right, we have what's known as a room temperature sensor. And for some reason, there are a lot of individuals out there that think this has something to do with they can actually use it to control the temperature within their space. You cannot. When you see these devices within your space, they are only just sensors. So what they are doing is these components, the room temperature sensors, are sensing the temperature in the space, and it is relaying that information back to the mainframe or the main system for the building automation control, or building automation system. The reason this is important is because we have to understand what the temperatures are within a space in order to provide it with what it needs. So if that sensor is saying to the mainframe, hey, we have about 60-degree temperatures within this space, we're going to need to warm it back up because the set point for that space is roughly 70 degrees. So what will happen at that point is, as that signal of 60 degrees is coming back from the room sensor, it's triggering the system to push more hot air into that space, so that way it could reach its set point at 70 degrees. So all three of these different sensors here has its uses individually for each application that it's going to be a part of. Next, we've got a few more sensors on screen. We are going to start all the way over to the left. We have a humidity sensor, and humidity sensors are devices that detects and senses any type of water vapor in the air. Humidity sensors also report the RH, or relative humidity. I like to go by RH of the air, or determines the amount of water vapor present in that air. The room humidity sensors can be found within different zones. So before I go into that one, I just want to touch back on the ambient humidity sensor. The ambient humidity sensors, like we mentioned earlier, detects the relative humidity outside of the facility. So anytime we see ambient, we know that it's going to be a device that is sensing some sort of measure outside of a facility or within the outdoors. It's important to different systems that needs that regulation of relative humidity to have these types of ambient sensors on their systems, because that way it will be able to let the system operate based on ambient conditions outside. So I'll give you an example. This is more of a basic example on a residential level. But if you had your system set up like this, it would operate just the same. But if you notice, on days when it's extremely humid outside, you may have to adjust your air conditioning to operate or come online, so that way we can reduce that humidity. If you have an ambient humidity sensor attached to your facility on a commercial level, what happens is you don't have to do any type of adjustment. Your building automation system is going to receive that high relative humidity reading or measure from that humidity sensor, and it will send it to the BAS system or BAS controller, letting it know, hey, we have extremely high relative humidity, and we're going to need to account for that relative humidity when the system comes online. So what we may need to do is come online right now. We know we're supposed to be offline, but we may need to come online right now in order to have comfortable levels within the facility. Because if you have any type of humidity that's extremely high outside, you will have it, you will feel it within your facility if you do not have adequate conditioning of that space. Now over to the right, from the ambient humidity sensor, we have the room humidity sensor, and these can be found within different zones within the conditioned facility. These sensors are used to report any type of high or low humidity conditions and allow additional modes of a system, if it's installed, to come online and condition that space. So your room humidity sensor and your ambient humidity sensor is going to be very, very important. Um, uh, And also they do pretty much the same thing. One of them is going to be utilized for outdoor use, and the other is going to be utilized for indoor use. Lastly, we have our dew point sensor. Uh, Dew point sensors are pretty much used to measure and monitor the dew point temperature. Now, dew point is pretty important when talking to your moisture controlled applications. We know that heavy condensation causes issues with our electrical side of the house and also our mechanical systems, and we want to avoid it at all costs. So, uh, if we were to take compressed air systems, for instance, these systems are very, very moisture delicate, and you want to make sure that your system is aware of the types of components it needs to bring online in order to eliminate moisture from that system. Because as we know, if we have any type of moisture in our compressed air systems, it's going to lead to equipment malfunctions. So the quality of the air that you use in compressed systems is very, very important to the end process. So we want to make sure that we have no moisture in the system, and having a dew point sensor and even the ambient humidity sensors will allow you to measure that reading and adjust your system accordingly. So that way you're not flooding it with any type of condensation, and it makes your end use equipment inoperable. Next, we have a couple different sensors here that will test and measure your water, air, and pressure. And these items here, as far as your pressure sensor and your water flow sensor, these are regularly replaced. I know for me in the field, I have replaced several pressure sensors on chiller systems, and they just go bad. I don't know if it's a manufacturer's flaw or what, um, but between the pressure and the temperature sensors that are installed on a lot of these chillers, they're always being replaced. But they're not a big item or a huge item to replace. Really, really small. It's just getting it out from where it's installed and then disconnecting the electrical connection to that specific sensor. But from left to right, we have first our water flow sensors. And these sensors are instruments that's used to indicate the amount of liquid gas or vapor that's moving through a pipe or a piece of conduit by measuring the linear, nonlinear mass or volumetric flow rates of that specific system. So a lot of the time, these water flow sensors, I know chillers contain them, so that way you know whether or not you have chilled water flow. Very important thing to understand in chilled water applications. So water flow sensors allow you to see when you have that chilled water flow and when you don't have it. And when you don't have it, that's when it is a problem, especially when it's being demanded. Over to the right of that, we have the air flow sensor, and the air flow sensor measures the amount of air, typically in CFMs or cubic feet per minute. And normally you will find these in your large air handlers within your commercial facilities. These work really well. I've seen them in a lot of different air handlers, and you can just come up to it, look at the LCD screen, and it measures out the exact amount of pressure, not pressure, but the amount of volume of air that's flowing through excuse me, flowing through an air handler unit or system. So really good device to have in your air handler units and systems. So that way you don't have to use some of the handheld equipment in order to get those measures or readings. And lastly, to the right of that, we have the pressure sensor, very important device. But pressure sensors does exactly what it is named. You should be able to measure the pressure in gases or liquids flowing through a system when you have a pressure sensor installed. This is found on HVAC and your boiler system. So you'll find these pressure sensors attached to your chill water systems, your split systems, your your RTUs, and also your boiler applications as well. Will have these pressure sensors, which will alert you to any type of high pressure setting or low pressure that is active in your system. So those was just some of the different mechanical sensors that you'll find that is located out there in the field. Now we're going to talk about some of the electrical sensors that you may find out in the field today. Now we've got a few here. We've got a power sensor, phase monitor, and also a voltage sensor. Now the electrical power sensor that you see here are pretty much used in electrical power grids across the United States and all over the world. Now, even with the even though you have automatic controls that are out there today, you still need to have trained personnel that are available to monitor these different sensors and these different uh, automated devices that are installed in these systems. And that's because if you do have something that goes wrong, just because we have the system on automatic, it doesn't mean that it's always going to work flawlessly. So we should have either overwatchers or different shifts of certain individuals, whether that's electric tradesperson or mechanical tradesperson, that will monitor these systems when we do have unoccupied times at these different facilities. Now, over the years, we've had the development of a lot of intelligent sensors, so equipment problems can be detected and reported with a lot greater efficiency. So if the individual that is on site is not qualified to work on that, they will receive an alert, which then they can contact the right individual to come over and check out whatever type of power quality issues that may be existing. Now, some electrical power sensors are incorporated into transformers or other components of the power distribution grid. Others are added to existing systems. Now, these electrical power sensors measure one or more physical characteristics and it converts them to the electrical signals, which can be read at the end device or whoever is overwatching or seeing the operation of that power system. Now your phase monitor, which is over to the left. Before I even jump into that, just really quickly, I think I did not mention this, but your power sensors are able to respond to any type of system problems, such as overcurrent, undercurrent, any type of voltage sags that you may have. And once again, I just want to make this repeat on this. Trained personnel are needed to monitor the overall grid and respond to specific equipment problems. So even though you have these different sensors and components attached to your system, and they are 24 hours, 7 days a week, constantly online, providing you with input, we still need trained personnel in order to monitor these systems. So that way, if there is an issue, they can be alerted of it and then make some sort of a fixed action. So once again, your power sensor is going to be responsible for letting you know of any type of overcurrent, undercurrent, or voltage sags that you may have within your system. Now, your phase monitor that is located directly next to your power sensor monitors any type of voltage drops um, or increases in voltage and helps to prevent damage to the equipment that it is connected to and injury to any type of personnel. I've seen these systems, the phase monitors, on a lot of different systems, especially systems that are extremely expensive. And that's due to the fact that you want to protect that system. And phase monitors are able to do that. They provide protections against any type of phase loss, phase reversal, which happens during connection of the electrical part of that system. Sometimes you might mix up your A and B connection and connect your B and C instead of A and B, and that will run your compressor in reverse. Now, if you have a phase monitor attached to that system, it will alert you immediately in the field, if you know an HVAC technician that has done a lot of work, they will tell you a lot of time. If they're like me, have done this for some time now, they may tell you that they can hear when you have a phase reversal of a system. I know for me, I can hear it. So whenever a compressor is running backwards, I can tell you immediately that it's running backwards. And the fix for that is typically reversing any two leads within your connection system, and that should fix the problem. But if you have a phase monitor or phase rotation device, monitoring device, you're able to get that alert. Hey, you're out of phase. You need to figure out why before you burn out this compressor. And instead of spending thousands of dollars on replacing the compressor, spend a few $100 to get a phase monitor that will alert you immediately if you have any type of phase loss or phase reversal. And sometimes these items, such as phase loss, phase reversal, can be due to any type of blown fuses, broken wires, or just simply worn contacts on the electrical system. Excuse me. And then lastly, we have voltage sensors, which provides 24/7 monitoring, constantly watching for any type of voltage drops or voltage increases within your system. And we know low voltage may be an issue, while having assets that that can be introduced to high voltage may become a significant issue. So you want to have these voltage sensors attached to equipment that either may have had issues in the past, or you're just overall concerned about the voltage within your facility. You could have these sensors installed, which will provide you with measurement and verification readings of those different devices. So all voltage sensors are devices used to sense low and high voltage in a system. Also provides you with 24/7 monitoring. Next up, we have step 2. As I promised, we'd bring back this this great little chart here. But before we jump into that, I just want to check in with Danny and see if we've got any questions thus far.
Yeah, Lester, I'm looking at the questions blog here, and it looks like there is nothing that is in there at the moment. So I will keep you updated if any questions come in. But again, to all attendees, if you have any questions, you can provide them in the questions tab or the chat, and we can respond to those.
Absolutely. Thank you for that, Danny. All right. So if we don't have any questions, I'm going to press forward and move into step 2. I did promise to bring back this this little pathway where we show our steps to evaluating our HVAC systems. Here is step number 2, which is determining the sensor location and available data. So we know that we're wanting to find at what point in the system do we want to capture this data. Can some sort of a sensor or component on the market be able to retrieve this data? And we went over some of those different sensor components that are available on the market to retrieve this data, but where are we going to put it? So determining sensor location. We have this lovely site here. Let me see if I can get my trusty laser pointer. There we go. So we've got our facility over here, and this is more of a lighter cutaway version of our facility, where we can see we've got some mechanical rooms here with air handlers. And it looks like for the most part, we have just a standard average office building here. Now, what we've done is on this side, we've kind of expanded that and shown a blown out view of where you may have sensors located throughout your facility. So some of the places that you can find these sensors are definitely inside of your equipment. So you will find it in your mechanical room. You'll find it depending on what type of a sensor it's for. If it's for directly measuring some sort of electrical value, it will be in line with that electrical connection somewhere. So that way it can send that reading back to the system for it to be read. So it could be inside of the system specifically, or somewhere close to the system, or even if it's a sensor that's measuring some sort of space or air or velocity, it will be installed directly in the system, such as such as the device or instrument used to measure air velocity inside of an air handler. So another place you can find these sensors are outside of the facility. So remember, we want to put an ambient temperature sensor uh, out here somewhere on the top of our building, kind of hanging off the ledge, with some sort of a shroud or a cover to protect it from the elements. But what it'll be able to do is it'll measure our temperatures at a decently high point with no obstruction. So that way it could send that signal back to wherever the mainframe is located in this facility. Or let's not forget that we can also have control to our facility outsourced. So your power or utility agency would be able to do a lot of the controlling as well. So outside and also indoors. So remember, we spoke about our room temperature sensors or room humidity sensors. We'll find these items inside of our facility directly on a wall located inside of that zone or that space. Our outside sensors, like I said, for example, the outdoor ambient temperature sensor or relative humidity sensor will be located at some point outside of our facility. So that way we can measure those different measurements. So location is key and important to trying to figure out what type of values you're trying to obtain. Do you want to know what your outdoor temperatures are? Do you want to know what the current temperature within a certain space inside of your facility is? So that way you can make it more comfortable for the occupancy. Or do you want to test the velocity of air coming out of your diffusers directly within each zone, right? So the air coming out of that little diffuser at the top of the ceiling blowing down into the space, you want to know how much velocity of air and CFMs that's pushing out into your space. It might be too much. And this office here may be complaining that it's too cold. And if you have that situation, you're going to have to remedy it and find out how to adjust it. It's also a bad use of, or we could say a waste of energy, to continue pumping in cold air into a space that doesn't require it. Yet you might have another space that is extremely warm and could use that airflow. So having these different sensors in place will allow you to do a lot of diagnosis on these different systems that you have set up within your facility. So once again, sensor location is extremely ideal. On the electrical side, that's just going to be cut and dry. You're going to pretty much put those sensors in line with the electrical application. But when it comes to sensors that actually test for something such as wind, air, water flow movement, those will actually need to be placed in line with that mechanical function or action. Next, we have step 3, where we're going to collect the raw data. During this phase, your data logger will be utilized to collect and store this raw data. The data log is run continuously and transfers this information to a database or a PC for analysis. So here is an image of your data logger. And once again, your data loggers are just electronic devices which automatically monitors and records environmental parameters over a specified set amount of time, allowing those conditions to be measured, documented, analyzed, and also validated. Then after it does that, it pulls that information. The information is stored directly in the data logger, and then it's transferred finally to a computer for analysis, which we'll get to here shortly. But we spoke about this. Data logging can be done manually by constant human observation. Um, so one example of this is when I was a young airman, one of my duties was to go to each one of our plants and take temperatures, also walk the facility inside and take temperatures in each office with a infrared thermometer temperature assessor or temperature device, temperature taking device. And then I had a pen and a piece of paper where I'd write the room number and what the temperature was coming from the supply vent and what the temperature was going through the return vent. And typically we're looking for a 10-degree delta T when we're taking those measurements. So that lets us know that the system is operating efficiently. Now, today, you don't have to do that. You can literally have one of these systems, your data loggers embedded into your BAS system, and watch how much time you're going to cut from that resource, that human resource. You'll be able to utilize that human resource now in order to make any type of emergency repairs or repairs period that needs to be done. Instead of going around and taking these measurements, your data logger can compile that information for you. So some of the different types of data that you can have retrieved from your data logger are temperature, humidity, single and three-phase power usage, CO2 values, MVMA values, voltage, pulses or counts. And pulses or counts, a lot of the time that's dealing with your VFD or inverter applications. But your your data logger is able to even pull those types of values as well. So very important, cool little piece of device available in your system to allow you to collect as much data as possible and store it until you're ready to pull that data for analysis. Then we've got we spoke about collecting the raw data and downloading it over to our PC. So our PC is going to be used to collect the data from the data logger and move it into some sort of a database that we can use for later observation and analysis. So the download portion, as you can see, we've got a PC here. We've spoken about the building automation or BAS system, which pretty much utilizes a control system to automate the control of various building systems, mainly our HVAC applications. So the BAS system provides this user interface that you see here that allows the end user to control any settings, view the system status, and detect any potential issues related to building system performance. So all of those nice little sensors that are out in the field, we've installed them from mechanical to electrical sensors. We've installed them in the field. We want to know the velocity of air going through the air handler. We want to know how much voltage is on each leg of power on our three-phase motor system. We want to know what the temperature is in room 103, supply and return temperatures. We also want to know what the relative humidity is in all of those spaces, to include what the temperature is outside today. We can sit right here after we've installed all those sensors and look at all of that information on this screen. And typically this is done by a building automation engineer or technician that is assigned to that facility to observe its energy usage and also its HVAC operation. So your BAS system is very, very important in your commercial sites, and it makes life a whole lot easier. Now you may have a desktop type station set up for this BAS system, or you can have a laptop set up, which makes it easier to move around and conduct any type of operations remotely, where you would need to plug your computer's RJ45 jack into a connection, or even the CTA 2045 systems. You can have access to that as well. Excuse me. So lastly, we have our last steps here from this evaluation, HVAC system evaluation process. And lastly, we have our processing of that data and analysis. And then what are we going to do with that data and analysis? So what we've got here is a 5-step process when using your data for audits or to perform any type of system update or upgrade. So what are some things we could use our collected data for? After 20 years of equipment use, if you have 20 years worth of data to review, you can look at whether or not your system is still performing as optimally as possible. But you as a manager, or maybe even the building owner, may not be able to do that. So you may call your utility company in, and they may conduct an audit. Now, the audit will start with potentially looking at any type of logs that you have and evaluating your power consumption at that point, right? And even watching your system in operation as it stands. Once that is completed, what will happen is there are questions that needs to be answered. You know, what type of issues exist? Do we need to perform an upgrade? Once again, any urgent repairs need to be made, or is all our maintenance up to date? These are the questions that are going to come up during your screening audit. Okay, the after the screening audit has happened, um, you'll have these auditors from your utilities company look at any type of existing drawings and identify any type of issue points within the HVAC system. And a lot of these inspections are going to happen right on site, physical inspections of the equipment and, like I said earlier, its current operating conditions. Now, after we have completed the audit, reviewed all of the available information, watched the system in operation, you're going to have an in-depth type of study for that specific operation. Okay, and the options that are going to be available, which this part here, step number 3, this is going to come from your utility company. So once they've done evaluating your logs and looked at your actual operation in step 2, now they're going to go back to their side of the house and determine what is going to be needed to either improve your processes, reduce your energy usage, or bring your system up to energy efficient standards. And then they'll come back with a package, which may include some incentives towards the equipment that you may need to buy, and also annual savings through um, lowered energy cost points. Specifically for you, if you sign a contract with that middleman or that utility company. But from there, if you're in agreement with what the utility is saying that they recommend, what happens is this equipment in step 4 is introduced, installed inside your facility or site where it's commissioned, and all the equipment is verified as operational. This goes through an extensive process to include the warranty process that's a part of it. But what happens from there is your system is going to be monitored for anywhere from a few months to a year, and then you'll have your post audit, which your post audit is pretty much going to check the usage and operation of this newly installed system to measure and compare any type of energy saving gains. So this 5-step process here, you'll pretty much find this happening with any type of system that has a BAS system, and a lot of equipment that has been in the use for 15, 20, 25 years plus. This is a great way of evaluating those systems through the logs, through operation, and then through your utility company making recommendations for upgrade of the facility components. And then from there, your post audit will actually show you what you have in energy savings. So we're going to just look at this slide here really quickly. And what we're going to do from there is take that first break. We'll take about 5 minutes, and then we'll come back and finish up our presentation. But we do have Phoebe that will come in here shortly, about 15 minutes towards the end of the broadcast. We'll have Phoebe come on and present some information for our attendees today. So before we jump on this break, just want to go through this nice process here that shows obtaining your sensor information all the way up to processing that information on your PC. So we know that what we understand what our sensor is, and it just basically takes the measurements of your ambient zone temperatures, relative humidity percentages, your air velocity. It also can detect smoke pressure and motion. So that is what your sensors are responsible for. And this little image here shows exactly what a sensor could look like. And this is one that fits in a well or some sort of a bored hole in chilled water piping. From there, you have your signal conditioning device or transmitter. And this device, we didn't talk about it too much, but this is a device that modifies the raw analog output signals which are produced by the sensor. So the signals that come from the sensor, we can't read it. Only this device can read it. So it conditions the information coming from the sensor and it sends it over to the data logger. And the data logger we just finished talking about is just a compact battery powered device with an internal microprocessor and data storage. And it's able to accept the data that we are looking for, hold on to it and its storage capacity until we're ready to transfer that information over to our personal computer through the spreadsheet that is available on that system. Now, we do have measuring instruments that are used to do everything you see up here, but by human process. So we'll talk about some of those different devices when we do come back from break. But down here, what you can see is the IR thermometer that I was talking about. This is the device that I used as a young airman to run around to about 150 rooms a day and take supply and return temperatures, write them down in my notepad and return it to the shop foreman for logging into our daily logs. So we can do away with that, even though this is good for emergency on-demand type of problem diagnosis, but we don't want to do this every day. It's a waste of, not really a waste of time, it's a waste of human resources, but we can if we can automate it using this system up here, okay? So what we'll do now, it's 6 after the hour. Before we get to HVAC system testing instruments, we're going to take a quick 5-minute break. We'll come back, see if we've got any questions, and then we will continue with our presentation.
Sounds good. Thanks, Lester.
Absolutely. All right, we are back. Hopefully everyone had a pretty good break. And what we're gonna do is jump right into HVAC system testing instruments.
Hey, Lester. I think before we do that, we do have one question in the chat that came from the previous slide here about the automatic sensors that I wanted to ask you.
Yeah, absolutely.
Okay, so the question was, is there value in periodically collecting data to make sure automatic sensors are still working well and not out of calibration?
Absolutely. That is an awesome question. The reason, well, I'll say this. I know with chiller applications, you'll know the sensor will not operate. Like it will give you some type of faulty value, like -8 million on the LCD screen or the logic controller of the programming or the programmer that you're looking at on your chiller's application. But there's nothing, the only way that we know how to monitor these systems is by having all of these different sensors connected to your BAS system. And the way we're able to identify that they're faulty is the master controller will send out a page to an HVAC technician and say, hey, I've got high pressure sensor on chiller number 2 showing negative values. So you'll pick that call up and you'll run out there and you take a look at it. You put your meter on that sensor, testing the electrical side of it, and you'll find that maybe it has bad resistance and it's ohming out pretty bad. So at that point, you need to replace it. But uh, using a BAS system is your way of tracking whether or not those sensors work. And also, when your technicians are going and doing their daily inspections or any type of interval of inspection, they should be able to catch when a sensor is inoperable. Hopefully that answers that question there.
Yeah, thanks, Lester. It looks like that is all for the questions that have come into the chat. But again, I want to remind all attendees that if you have any questions that arise during the presentation, please put them into the chat and we can discuss them here.
Absolutely. All right, so we've got that ironed out. We will dive into HVAC system testing instruments. Now, facility checks are provided manually by HVAC technicians who are using the tools of the trade to obtain the data points that we're looking for. And this is critical to any type of troubleshooting that may be done out in the field. So when testing your HVAC systems and applications for efficiency, the following should be taken into consideration. So you've got a few different systems here: boilers, chillers, air handlers, and your power, which we'll talk about here shortly. But before we talk about those, we want to know, when looking for looking to check the efficiency of your applications, what is your for the first thing that we're going to look for is the level of understanding. What is your level of understanding? How much do you know about this system or understand about its operation, or where can you learn more about the system and its operation? Accuracy and availability of any type of existing data for any of these systems that you see here. Now, this is where your sensor information and data loggers become key. We can allow our auditors and other examiners of your plant, whether it's mechanical or electrical, to analyze this data within the database to see where improvements can be made. And we spoke about that in that 5-step process. Information information from your maintenance room logbooks can also be key in evaluating or making recommendations which would improve the efficiency of your actual overall site or the specific drill down to the specific application, whether that's your boiler or your chillers or your air handlers or your pumps. Time. What's your availability to do this testing, to do this efficiency testing? Do you have any available downtime? Can you afford to have your systems taken down for inspection without any type of mission loss? Is scheduling an option for downtime? Can you schedule it for the weekends? Is that a possibility? Can your system accept the backup utility to continue operation? I know I've been to many bases that has that. They have connection points for chiller systems where I could have a portable chiller brought in on a trailer, and then my team will connect the applicable hoses to that site, so that way they have chilled water still moving through their system whilst we clean the existing chiller. So scheduling and downtime is something that should be taken into account. And also financials. Is the site financially capable of improving the efficiency of mechanical systems or electrical systems? Are there any incentives available from your utility companies for making these upgrades, which I'm sure there are. Um, there are a lot of incentives out there to improving these different systems. You just have to uh, start looking for them. So what we're going to do here is we're going to go into some of these different systems and talk about the types of instruments used to test these systems, which I know a lot of you have been waiting for. So we're going to start off with boilers, and you can see here regular boiler test assures higher efficiency and reduce maintenance of boilers, which is important. You want to make sure boilers, especially, you're doing your maintenance on it, because these systems can become dangerous if they're left out of, not only dangerous but unreliable if they are not maintained properly. So some of the things you're going to be testing for in your boilers are testing for CO2 leaks or any type of CO2 detection, your boiler water quality and the chemical treatment of that water loop, testing for any leaks that may be happening on your supply and return heating water lines. And you're also going to test for proper combustion in your combustion chamber for that boiler system. And then also you're going to be sending supply and return temperatures of your hot water supply to your BAS system or your building automation system. And we all know that's for logging. We want to make sure we have all those diagnostics inside of our log. So when we return to it at a later date, we can have those readings for evaluation. Sending supply and return of the air handler unit temps during heating applications to the BAS. So not only are we sending the water temp, supply and return to our BAS system for logging and reading by the master controller, but we're also sending the supply and return temperatures of our air handler system during the heating application to the BAS system as well. Now here on screen, we've got a few instruments that are used to test boiler systems. From left to right, we're going to start off with our pH balance test kit. Now, it's essential to maintain the correct water conditions, and not only for boiler water or heating water, but also for our chilled water systems as well. But by monitoring the boiler and chilled water systems, we can avoid scale formation, reductions in efficiency. We can improve the purity of any type of steam that we're producing, and also eliminate any corrosive water conditions. So a pH balance test kit is necessary on site. I think a lot of these, it's been a long time since I've used one of these, but I believe they come with instructions. So you can actually have these at your site and use it to test your water conditions before contacting a contractor. So, excuse me, you might test your water conditions and find that it's naturally balanced, and you won't probably need any type of chemical treatment solutions. But for different regions of the country, I know for sure in Texas, the water down there is extremely hard. So we had to use water softeners in our chiller applications. So that way we wouldn't rust out our pipes within like five to 10 years. So yeah, pH balance test kits are important just for testing water quality. But always remember, you should have some sort of trained water specialist or a contractor that can come out and perform these services for you. Next, we've got a combustion analyzer, and this is for use with gas propane fired boiler systems. For these types of systems, you want to make sure in your boiler and your gas systems, you want to make sure you have proper combustion. And this helps with efficiency of that system. So flue gas analysis, when you want to perform that type of inspection or testing, you would do so by inserting the long probe that you see here on, looks like almost like a gun type handle, and you have a probe that's attached to it. You would insert that probe into the flue of the furnace or the boiler during combustion, and this would give you exactly what your combustion analysis is. So once again, flue gas analysis in HVAC systems would allow you to check for any type of bad appliance exhaust, see if you have any type of a cracked heat exchanger, leakages as far as CO2 leakages, and also your indoor air quality. So it's important to have the analysis done of your gas combustion within your boiler systems. So that way you make sure that the system in itself is, one, combusting as efficiently as possible as far as creating the heat that's required to heat that water, and also to make sure that you don't have any issues with your system such as leaking of CO2. And also it could tell you whether or not you have some sort of a cracked heat exchanger within your system. And over to the right, we have eddy current testing, which is also used on chilled water systems as well. Eddy current testing is just a non-destructive testing method, which is used to examine the tubes inside of heat exchangers, steam generators, condensers, chillers, and also feed water heaters. So what this does is it has these probes that you run down the tubes of a system. I know the one that I used to use 15, 20 years ago, it was much different than this. And it was a lot more complex and complicated in its use. The ones that are available today are probably a lot easier. But what we would do is send probes down the tubes and inspect the integrity of that tubing bundle to make sure there were no cracks, any type of pitting that would affect the efficiency of that tubing bundle. Next, we have up our system testing instruments for chillers. We just covered boilers, and now we're going to talk about what types of instruments out there are available for testing our chill water systems. Now, chiller system testing, we're doing this to test for refrigerant leaks and a proper refrigerant charge. So we want to make sure that the refrigerant in our system is charged critically, and we want to make sure that there are no leaks, no signs of oil residue. That is on the refrigerant side of the house. On testing the compressors associated with our chillers, we want to do oil tests, pressure tests, and also electrical integrity tests. On our condenser side, which are all these fans that you see up here of our system, this is an air-cooled chiller, by the way. We want to check the electrical integrity of these fans, the fan motors, but for the fan blades in themselves, we want to check for the free movement of these fan blades. So when you're performing your inspections, you want to take the shroud off and you want to put your hand in there, make sure the system is offline, but you want to put your hand in there and try to freehand spin that fan blade. And if it does not do so, it is seized and needs to be replaced. You also want to test your coil integrity through eddy current testing. We just spoke about that in water-cooled applications. Check for pitting, any type of corrosion integrity of piping within the exchanger. And lastly, for your chiller systems, you do have pumps associated with them. You want to do a motor integrity check on the electrical connections. You want to verify free operation of that pumping system without obstruction or mechanical failure. And also, you want to use a multimeter for the motor to check the voltages and amperages, and a tachometer for rotation. So tachometers we'll touch on here shortly, which checks your rotation of your motor system. So here are the instruments, or some of the instruments that we're going to use to test for efficiency on our chiller system. On the left here, we have refrigerant gauges. These refrigerant gauges test for the pressures of a chiller system, and you want to maintain your chiller pressures. And this is due to a lot of these systems having the need to be critically charged. This will allow the most optimal operation of that chiller system. Now, the gauge that you're looking here are Testo gauges, and Testo has the ability to calculate superheat and subcooling values within this device. I own a set of these Testo 550s. When I was actively in the field, this was one of the best set of gauges I have ever owned, and it provides a lot of information that you don't have to do manually. But I'm a really strict person when it comes to making sure I'm doing the correct work. So what I did for a number of years was carry this gauge and also a set of manual gauges that is not digital. It had the two gauges that had the needle points readings on them, and that is what I compared to anything that I received on this digital gauge. I am not knocking the digital gauge. I love them. But the thing is that I just like to verify more than once, especially when dealing with some of these sophisticated pieces of technology. So your refrigerant gauge is going to be important for measuring your refrigerant pressures within your system. And you have several different types of refrigerants that are out there. So make sure that the gauge that you're using is rated for that specific refrigerant system. Next, we have eddy currents. We spoke about that. And pretty much your eddy current testing is just for the testing of piping and your heat exchanger integrity, making sure there's no pitting within that piping system or the integrity of the pipe in itself is compromised. You'll be able to tell all of those different things with an eddy current test. Your multimeter, this is going to be used to check any electrical integrity of the electrical circuits within a system, such as your motor system, your compressor system, your fan motor system. You're going to want to check your integrity by using a multimeter in order to do so. So you can check for voltage, check for ohms, check for resistance. You can even check capacitance if you're looking to check the integrity of a capacitor. And then lastly, to the right, we've got our leak detector, which simply does what it's called. It detects for refrigerant leaks in your system. I love this thing. I have one or two of them in my toolkit, and it makes searching for leaks extremely easy by using this little end here to sniff out any type of refrigerant that may be in the air from a system. So it makes identifying leaks in the system much more easy. Uh, if you had to do this without this leak detector system and did it manually, what you would be doing is filling the system with some sort of a gas, such as nitrogen, and then going along the refrigerant lines or the line set and spraying it with spray bubbles or soap bubbles in order to identify where that leak may be popping out from. So the leak detector makes life 100 times easier. Does cost a little bit, but once again, it does make your job a little easier to bear with. Next, we've got the testing, adjusting, and balancing of the air handling unit. And all of these things is a vital step for complex air and hydronic systems that you will find at a lot of commercial sites and throughout campuses across our nation. Now, these types of systems to be optimized for your occupant comfort, energy efficiency, indoor air quality, and the manufacturing process, there are different types of equipment or components that are available to test these systems, such as flow hoods, which create balanced air systems. I always get this one messed up. It's been and I'll get it here shortly. I'll get it here shortly. I'll speak this word. We'll see it on the screen next, because for some reason it always gets me, but I'll get it here shortly. Our IR thermometer, multimeter for motor testing, we've seen that, and static pressure readings are gathered by manometers with pressure probes. So this is what I was referring to, and I'll show it to you here shortly. So we named off some of the different systems or components or instrument testing components that will be used on air handler systems, from flow hood to this one here, it always seems to twist my tongue up. And I get it, but every now and then. And I want to say it's an um, I can't. I'm sorry. I really cannot pronounce it this morning. I don't know why. But the name of it is here on screen, and I'll tell you what it does here shortly. But let's start with the flow hood. I've used these flow hood systems, not this one by Testo, but similar brands in the past. But what flow hoods are used for is for air balancing within your commercial system. So wherever you have your 12 by 12, either the supply diffusers or return vents or grills, you're going to use a flow hood to make sure that the cubic feet per minute of air that's flowing through that supply or return ducting system is what is listed on your blueprint. So you have blueprints that are capable of showing what the specific volume of air or velocity of air needs to be flowing into that space. So what you want to do is you want to pull those blueprints out, you want to bring out your flow hood, and you want to test for that. The flow hood is a lot more accurate. I'm going to just call it the anemometer for right now because it's really making me upset that I can't say this word. I don't know what's wrong with my tongue this morning. It won't say the word the way it needs to be said. Or maybe I'm saying it right. I don't remember. But the anemometer, we'll call it that for now. I want to say it right. It's the anemometer. Anemometer. Maybe that's it. This is used to do the same thing as your flow hood. I carry one of these in my tool bag, and what it's used for is to test air velocity in CFMs as well. But this is more of a portable version of this really, really huge one. But this one here is more of a how do I say this? This will give you a lot more accurate, tighter readings because what happens with this flow hood is you're actually going to fit this entire hood over the vent. It goes over the entire vent and encapsulates the entire vent, so that way it gets a really solid reading. This is going to just be placed over the vent. It won't cover it up or anything because it's really, really small. And it'll give you a roundabout area of where your CFMs is at for that specific supply or return vent. And over to the right, we've got our IR thermometer, and this is just used to obtain supply and return temperatures from different types of equipment that emits heat. So you can use these devices on your fan motors to see how much what the temperatures are of a pumping system, of some fan motor systems from your supply and return air ducts. You can use these little devices for a lot of different temperature measurements. So I like to keep one of these in my tool bag as well, because it is good for catching really quick temperature measurements. And then your tachometer over to the right here is used for testing the rotation of motor applications measured in RPMs or rotations per minute. So motor RPMs, for those of us that are not familiar with motor systems, they do have a data plate on them. And those data plates, you can retrieve the RPMs rated for that specific motor. So if you have a tachometer, you can check to see whether that motor is running the rotations per minute that it has rated on its data plate. So we're going to pause here really quickly just to check in and see if we've got any questions so far.
Hey, Lester. It looks like we had some attendees have some good pronunciations here for the anemometer.
Anemometer, that's it. That's it. I just can never say it right. It's been like that for years. I had an instructor when I was in the military that made fun of me for that. It was terrible, but yeah. Thank you for whoever brought that up. It will be remembered for the rest of the day. Anything
Right.
else, Danny?
And we also had some other questions here. They're wondering about when to use the psychrometer.
Psychrometer, 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 psychrometer. Let me just look that up really quickly.
For relative humidity, it looks like.
Oh, I haven't used one of these in a while. Yeah. So wet bulb, dry bulb, measure content, moisture content, or relative humidity of air. So yeah, so it's psychrometers. Um, Psychrometers are used to measure relative humidity of the atmosphere. Uh, so the devices the components that we spoke about earlier, such as the ambient relative humidity temperature or relative humidity sensor, those pretty much do the same thing. So if you're looking for any type of relative humidity or moisture measurer, you'll use a psychrometer or any type of ambient, not ambient, but or you could say ambient, but ambient RH relative humidity sensor would be able to assist. Hygrometers as well um, can do the same type of testing and measuring.
Did you say tachometer?
Hygrometers with a H.
Okay, gotcha. We do have another question. Could a tachometer be used to estimate the load on a motor?
No, tachometers are just going to be used for rotation testing. So RPMs, rotations per minute, you'll get that. If you need to know, sometimes here's a great use for the tachometer. If you go up to a really old motor and it doesn't have a data plate, you can put the tachometer on it and it will tell you what the RPMs are for that motor. So now you know whether that motor is oversized for your application or undersized.
Awesome. It looks like those are all the questions we have for now, so we can start moving on.
Okay, awesome sauce. So let's try to get through a few more of these before we hand it off to Phoebe here shortly. So HVAC system testing instruments. So our electrical counterpart has components that or testing instruments that are used for testing electrical components as well. So we'll go through some of those so that way you're aware of what those different testing instruments are. From the left, we have our megometer, and the megometer, or also called in the field an insulation resistance tester, is a type of ohm meter used to measure the electrical resistance of insulators. So any type of insulation resistance test measures the total resistance between any 2 points separated by electrical insulation. So this test determines how effective the insulation is in resisting the flow of electrical currents. So the megometers are used. I seen these used a lot when testing your switchgear systems and just making sure that the insulation on the conductors are well situated, so they're not peeling, they're not giving way, the integrity of those insulated systems are up. Over to the right, we have our IR electrical thermal imaging devices. Thermal or infrared cameras, for those of us that are not sure of how they work by converting emitted radiation levels into a two-dimensional picture that will highlight contrasting energy levels. Usually when that happens, you can tell whether or not there's some sort of electrical fault when the temperatures start getting brighter in color. So like I said, for the megometer being used on switchgear, this thermal imaging system is used on switchgear a lot as well, because a lot of the time your switchgear is unable to be switched off unless you have it scheduled to be switched off. Excuse me. You can use these whilst they're online to test where you may have hotspots in the system. So when you do get ready to go back in, you've already identified where to start your diagnosis and troubleshooting. These are very expensive systems. I believe we bought a couple of these for our electricians out in the field at at the embassies, and it was up there, pretty pricey stuff. But it does make the job once again a lot easier. Over to the right here, we have our electrical digital multimeter again, and this meter here is going to do the same thing, which is measure and test for um, electrical integrity through voltage, current, amps, resistance over our electrical systems. And then lastly, our oscilloscope. You won't see these too much in the field, but wherever we're doing some pretty hardcore testing, we'll have an oscilloscope which tests and displays voltage signals as waveforms, a visual representation of the variation of the voltage system over time. So these signals are plotted on a graph which shows how the signals change. And if you ever have an opportunity to see these in operation, they are pretty cool devices, and it shows you how your power is moving through your site. Now we do have a check for understanding here. We will skip that because we are running a little behind on time, and we do want to give Phoebe a chance to go through her presentation. So what we're going to do now is talk about system evaluation and testing. So that way you have an understanding of how some of these different HVAC systems are tested. We have a compressor jigsaw that I wanted to get into, and I figured we might not have enough time to do it, but you do have a copy of the slide deck, and I'd encourage all of you to go ahead and take a look at this. But from this compressor jigsaw, what you're going to do is just take a look at the videos that are here, and it shows you how each one of these different parts to an HVAC system is tested. And it's a very, very cool part of our presentation, but unfortunately today we won't have the op to get to it, but you can, on your own time, go in and take a look at these different videos to see how these systems are tested for efficiency. So HVAC system evaluation. Now we're just going to take a really quick look into how we're going to evaluate these systems. So with your package unit RTUs, we're going to take a look at enthalpy controls of your economy cycle. And this is just where you're bringing in fresh outside air into your system. You want to make sure that those controls are operating and able to bring in 100% outdoor air when the system is calling for it. When you're assessing your economizer performance, you want to make sure that the system is operating as far as the actuators and the dampeners that's used to move back and forth. You want to make sure that those systems are able to be controlled manually. So you at the actual system able to physically open it and close it. And also if it has any type of controls that are associated with that system. So that way it can open and close it remotely for the different types of settings that it will be required to operate in. And these economizer systems, they don't take a lot of cleaning. That filter system that's on the front here is typically pull out and wash. So you take that out, wash it, and drop it right back in. But that would cover your packaged unit as far as enthalpy controls or incoming free cooling on that system. And then any type of filters that you have on your package unit RTs, you would change those if they're not washable. And you'd also clean your coils and wash those coils, whether you're talking about your cooling and or heating coil. Next, we have our air handler unit, and some of the things you're going to want to check into is your dampeners. Once again, make sure that those are operational, whether manually or remotely. Any type of filters, filtration systems that you have, you want to clean those. Your heat exchangers, which are your heating and cooling coils, you want to make sure that those are nice and clean, no dirt and grime buildup. If so, you want to run a hose over them and clean those coils out. And also your fan motors, you want to check electrical integrity of those systems, and your belts, make sure everything is in operation if it's not a direct driven fan motor system. Your chiller system, you want to make sure you absolutely have your remote monitoring working, so all sensors are operational and doesn't have any flaws or faults. You want to make sure your coil is clean, compressors, refrigerant pressures are up to date, and you might want to think about installing some sort of a VFD system on your chiller application, whether that be your pumping system or your compressor system. So that way you have that system running extremely efficient. You do want to run logs, make sure you're monitoring and writing down your logs, and your tubes and also your coils. You want to make sure those are clean and those coils are able to have a great heat carryover or exchange during its operation. We do have another case study in here that we do run during our presentation, but unfortunately we won't get to that today, but you do have the opportunity to get to it at a later time when you do review the deck again. So that was system evaluation and testing. We had an opportunity to look at the different instruments used to test our HVAC systems and also electrical systems. And we did run through some maintenance procedures when talking directly to the different HVAC applications that are out on site. That does conclude DNR's presentation this morning on HVAC systems testing for energy efficiency. And now we will bring in Phoebe for a presentation here, and we will see if we have any questions once Phoebe is done with her presentation, once we come back on our end.
Excellent. This is Katie again at the Lighting Design Lab at Seattle City Light. Thank you, Lester. That was great. And I am going to introduce Phoebe Warren, who works in an adjacent division at Seattle City Light here as an energy management analyst. Oops, I'm trying to show my screen. I need to change the presenter, guys. I will see if I could do two things at once. She works in programs that offer funding for high efficiency HVAC in new and existing commercial buildings. And she's going to explain how some of the stuff Lester talked about works in these programs. So Phoebe, go ahead and I will do the slides for you. Oh, Phoebe, if you're talking, you are on mute. Let me check and see. Yeah, we can't hear you, Phoebe. Okay, well, Phoebe may have dropped off. Let me see if she's back in the waiting room. She's not. While we wait to see if Phoebe can get her audio working, if you guys have any questions about the information that Lester presented, go ahead and put that in the chat. We still have time. I am gonna go on mute for just a second, Lester and Danny, and see if I can call Phoebe.
Okay, sounds good.
Hello?
There she is. Hey, Phoebe, are you ready to go?
My apologies. Yes, I'm ready to go.
Excellent. Okay, we've introduced you. I'm going to go to the next slide, okay?
Okay, thank you.
Yes.
So, good morning, everybody. Thank you, Lester, for a great presentation. I'm
Oh, gosh. I think we lost you again, Phoebe.
territory. Seattle City Light has been offering energy conservation funding to commercial and industrial customers since the 1980s. Over time, the programs vary and they differ depending on the type of building and technology. So if you're in our service territory or work with customers in our service territory and would like to explore the options available, contact our energy advisors. They not only know our full range of programs, but they can forward you to an expert in the particular program relevant to your building. Next.
Did the slide change for you, Phoebe?
So I'm going to now zero in on the specific programs that are relevant to on-site testing and monitoring. And I'm going to cover first the programs that are specifically about, in effect, testing and monitoring. Within our retro commissioning program for existing buildings, there's a component offering that's monitoring based commissioning, whereby the customer has a building automation system that includes fault detection and system that is going to be in operation for at least 5 more years. And I think to the extent that building automation systems, which can be difficult to debug and understand, to the extent that they can use their multitude of components and complexity to diagnose faults and problems and help the customer, that's going to be a fantastic future for us. So I encourage you to consider that option. We also have a deep retrofit program whereby if the customer is able to save 15% of their total electricity consumption annually over a 3 or 5 year period, they will receive funding based on that drop in total building electricity consumption. So here, the utility is looking at measurements of total building performance, but of course the customer, in order to be successful, would be looking at their trends and whatever they can to identify capital and operational improvements. Next. Then moving on to talking about other programs for which testing and monitoring may be components but aren't really the primary target focus. For existing buildings, of course, as Lester explained, it's really important to use testing and monitoring where appropriate to identify problems with the existing building so that then the customer can either do their own changes with their own funding, or they can come to City Light to seek financial help in upgrading their system. And then on the other end of City Light funding, at the other end of projects that receive City Light funding, City Light uses testing and monitoring to determine whether or not the project is qualifying for payment, or either at the full amount stated in the contract, or perhaps at a lesser amount based on what is found on site. Next. So now I'm going to focus on that last approach. And so what I've done is I've started it with the really big picture of all our funding programs. You talk to the energy advisors, and then there are these 4 different uses of testing and monitoring in various programs. But now I'm going to focus specifically on where testing and monitoring is used prior to payment in a program where we have a contract with the customer and we're checking prior to payment that the scope of work stated in the contract has been completed successfully. And what we're looking for at that point is whether or not the equipment is operating. Is it actually off in alarm? Is it on? Is it in automatic normal control? Or is there some kind of manual override of the set point? Or is it in manual off? And I find not infrequently there is one of these non-standard states in happening when I first walk on site. And so once they get it into normal automatic control, then the question is, does the equipment automatically control successfully to its set points? And does that set point match what is expected in the sequence of operations that was written by the designer? And then finally, we're looking at whether or not the equipment is able to operate not just when I walk up to it and look at it, but whether it's operating successfully through its full range of operating conditions. And these days, most particularly, I'm concerned about whether or not the high efficiency heat pump or heat recovery system that we're funding is in use rather than the backup, less efficient electric resistance or natural gas system. And most of the time I find when I first go on site, it's switched to the backup system because the more complex high efficiency system isn't yet debugged. Next. So then the question is, what is our process for testing and monitoring of a system prior to payment? The most critical part is getting the process written down in writing as part of the funding agreement so that the customer, before they start construction, knows what is going to be required of them prior to payment. That way they can put any responsibilities surrounding monitoring and testing into their agreements with contractors. And what I do on really large projects is I'll send this, or even small projects, is I'll send this language to the contractor and customer before I send the agreement out for signature, so that if there's any objection to what I'm proposing, they can give me feedback at that time. I've almost never had anyone object. It's important not to make the prepayment process too laborious. But the problem is, of course, if you don't get that agreement up front at the time the project is done, people have a different sense of urgency about getting payment. And it's good to have in writing up front an agreement as to what's expected. Now, of course, we're not going through this process for many projects. It's just for large, complex projects. For lighting, the efficiency of a lighting fixture is tested at the factory, and we look at the model number and the submittal to reflect the manufacturer's testing, not our own. So I'm not talking about most of the city light projects here. So when we write up that process in the funding agreement, the prepayment process, we try to build on any commissioning that's already being done for the project. There are now a multitude of organizations that are promoting commissioning. It's required by the Seattle Energy Code and LEED. It's promoted by a lot of third-party certifications. So we don't want to have each organization looking at their own process. So we build on the commissioning that's already being done, but we try to let the customer know ahead of time, well, what part of that commissioning is relevant to us. And if we have something extra that the others aren't interested in, we can add that in. Oops. Let's see, I just did the wrong thing. Sorry, I'm trying to find my screen.
And Phoebe, we're right at 12:01.
Okay, well, we can stop there. That's fine if you like. I'll just put in two more words here. One is that you really want to enforce for whether, regardless of your role in a contract, you want to enforce and post on the mechanical room wall both the schematic drawings and the sequence of operations in any construction project, because the data means nothing unless there's an expert around who knows what it means. And someone on site needs to know how the system's supposed to work. Increasingly, with the types of things that we're monitoring and testing, understanding the system is not easy. So before moving to reviewing trend logs, make sure that you've written down, you've looked at the sequence of operation and you check that whatever trends you're looking at and your own understanding of the system are directed by the designer's sequence of ops as corrected if necessary by the contractor. Okay, thanks.
Thank you, Phoebe. There were a couple more slides that Phoebe has. They'll be included in the handout that we'll post to our website, lightingdesignlab.com, within the next week with a recording of this presentation. And here I'll leave this end slide up. An important number to know if you're going to start an energy efficiency project in our service territory, give them a call at the Energy Advisors. And thank you again to Lester and Danny from DNR Learn for our first time HVAC systems testing class. That was really great. As soon as I close out this presentation, there's going to be a survey to take. So if you would please spend your December 1st taking that survey. I'm sure there's lots of surveys for the end of the year, but that would be really helpful to us. Thanks again. Any last comments, Lester or Danny?
None on my end. I just want to thank everyone for joining us again today. And if I don't, I probably won't see any of you again, maybe till next year. So happy holidays and enjoy the rest of your weekend.
Thank you so much. Bye, everyone. Did it end?